Okay. All right, so let's look at problem number 2. So problem number 2 is asking me a couple of different questions. So let's go ahead and take a look at what it wants to know. So in problem number 2, the first thing it's asking me is what is the measure of angle EJB? So on this angle here, how does that relate to the measure of this central angle right here? So first of all, what kind of angle is this since the vertex is on the circle? An inscribed angle. And so remember a second ago we said on the inscribed angle, the measure of the angle is equal to half the arc, correct? So if the angle was 50 degrees, what would the measure of this arc be right here? Now remember that the angle is half the arc. So the arc is bigger, right? It's 100. Now this angle BOE is what we call a central angle. So on the central angle, the measure of the angle is equal to the arc. So since the arc is 100, what's the measure of the angle? Right, 100. Very good. So that takes care of kind of like the first question. So how would you compare these two angles? Is one bigger than the other? So if I asked you, how would you compare angle EJB to angle BOE? Are they equal, less than, greater than? What's the relationship? Well, angle EJB is that the bigger one or the smaller one? That's this angle here. Is that bigger or smaller? Smaller. So since it's smaller, how much smaller is it? It's right. So it's half as big, correct? So we would say that it's less than and that it's only half as large. Okay? Now, if I know what angle BOE is, then how do I find the measure of this angle here? Angle BDE. It says the measure of BDE is blank minus. Okay, so let's erase some of these other values here. We already know what this arc is here. We know that this is 100, right? This angle is what we call the exterior angle, so it's on the outside. So whenever you have an exterior angle, the measure of the angle is equal to the difference, so you have to subtract, of the two arcs. So one of the arcs is 100 for the sake of our example. And this is the other arc right here, correct? All right. So the question is, how might we find that value? Do you think it's equal to it? Twice is okay. You think the angle's bigger, or are we talking about to find this arc we're going to take 360 minus x, correct? And this one let's just say is x. So if we take 1/2 of 360 minus x, that's 1/2 of 360 minus 2x, and then if we take half of each of those, we get 180 minus x. That's what the measure of this angle would be. So it's 180 minus x. And you'll be able to watch these again to go through it again if you need to, okay, honey? Okay, so let's look at question 3. All right, so let me see if I can open this. There we go. So on question number 3, it's asking you a couple different things. Here are the values that you're given. The first question is, what is the measure of central angle LOP? Well, since angle LOP forms a straight line, that's where that 180 comes from. Okay? Because this is a straight line, or also referred to as a straight angle. And it looks like it forms a straight line. The next question is asking you, what is the length of LP? Well, if this radius is 8.2, what's the measure of this radius up here? First of all, what's LO? If OP is 8.5, what's LO? 8.5. So the question is, what's the length of the whole thing? So it'd be 8.5 plus 8.5 because it would be both radii together. What does that equal? 17. Very good. And then the last question says, what is the length of MP? So what you do is you have a triangle. You know that this side is 8 and this side is 17. So how do you solve for the missing side when you have a right triangle? You want to use what's called Pythagorean's theorem. Remember, a squared plus b squared equals c squared. Now, c is the hypotenuse, so that's going to be 17 squared. And then this is 8 squared plus b squared. So you get 64 plus b squared is equal to 18 squared, which is 289. So what would b squared be? How do I find b squared? You want to go ahead. Well, what were you going to say? Sorry. You want to take 289 and you want to subtract 64 from both sides. So what will that give you? $225. So B is equal to 15. Questions? Okay, so then this next one has to do with that exterior angle again. So we just talked about how you find the exterior angle. What did we say was the formula for finding the exterior angle? That's the one that's half the difference. Okay, half the difference. So the first thing you want to do is find out what this big arc is. And remember, how many degrees are all the way around a circle? Okay, no, not 180, but 360. Okay, 360 to go all the way around. So if I subtract 109 from 360, what do you get? I'm going to let you figure that out. I need to run to the ladies' room real quick, so while you figure that out, I'll be right back. The way you do this is the measure of the angle is equal to that 251, or which is this angle out here, or arc, the larger arc, minus the smaller arc, which is 109, and then you divide that by 2. So go ahead and calculate that for me. So the measure of the angle is 71. Very good. Questions? Awesome. So do you see how these rules, we're using the same rules over and over again? Okay, so let's go through one more example here. This one's got a few. All right, so what type of angle is this since the vertex is on the circle? It's not inscribed. I'm sorry, it's not on the circle. That's what I said, but I meant this angle, angle C, where the vertex is on the center. Right. So on the central angle, remember the measure of the angle is equal to what? Right. This is equal to 109 because the measure of the angle is equal to the arc, right? Because it's on the center. Here's the inscribed angle. Now we know it's inscribed because where's the vertex? It's on the circle. So do you see these little marks here and here? That means that this is also 109. So since it's on the circle, the measure of the angle is equal to what? Remember, these aren't equal. What's the relationship between this angle and the arc when the vertex is on the circle? It's equal to half the arc. Okay, so what's half of 109? 54.5, right? Here, if you know, again, how many degrees is it all the way around the circle? 360. Since we already know that this part of the circle is 220, when we subtract that from 360, we get 140. That means there's 140 between A, C, and B. So since these two are the same, that means this one's 70 and this arc is 70. So do you see how I got all those pieces? Okay. So the question here was, what is the measure of the angle AOB? In order to answer this question, what is the measure of angle OAC? We have to first find what the measure of these other angles are here. Now, we know that angle A and angle B are the same. We know that angle O is 140 because it's on the center, so it's equal to the arc. We also know that angle C is an inscribed angle, so it's half its arc, so that's 110. So together they add up to 250. If I subtract that from 360, I get 110, and that means these two angles together equal 110. So when I divide that by 2, the angle is equal to 55 degrees.